Okay, so in this video, I'm going to title it Variables and Equations in Context. And what we're trying to do is, now that we've talked about how to translate sentences into math, we want to start actually doing some practical things. Okay, so you might be asking, what do I mean by in context? And that's exactly what I'm talking about here, is that with real wording. So the kind of problems that arise in the world that require math. But in a lot of cases, first we have to at least interpret, but also sometimes translate to get things into math. Okay, and one important thing to understand is that most practical wording, most practical problems actually involve two variables. Okay, but it's not as complicated as it sounds, and so we have two variables, but where one depends on the other. Okay, so if you've seen or remember one of my previous videos, I talked about the cost to ship a certain package. Okay, I would have to look back to see what that exactly what the exact example I used. But say I told you that I have these two variables. I have let's call it C for the shipping charge at a certain company, certain shipping company, and so I have a shipping charge, and I'm going to call that C, and then the shipping charge is going to depend on the weight, so I'm going to call that W. Okay, and especially in cases where there's different kinds of units, you usually want to give what kind of units you're giving. So here we mostly measure weight in pounds. Shipping charge, that is, it's usually pretty obvious that it's in dollars, but technically we should say that. Okay. Now, very often you're given an equation. Okay, like that. Not always, but very often. So say I give you that we have this equation right here. C equals 1.10W plus 1.5. Okay, like that. So here, this is just an example of me stressing this idea of two variables. Okay, what this is saying is, remember C is the charge. Remember the word equals translates to is. So you can kind of translate backwards if you want to try to understand this. C equals 1.10 times W plus 1.5. And so what that's telling you is that whenever you go to ship a package at this company, they determine the weight, W, and then to figure out how much they charge you, they multiply that weight by 1.10, and then they add 1.5, okay? And then that ends up giving them the charge, all right? And so there's a couple things to be taken out of this after on the next slide. But the main thing right now is to understand, just to start seeing that a lot of in context kind of situations, there's two variables, but it's not as complicated as it seems, because in most times one variable depends on the other. That means that you're going to have like C equals, or whatever this variable is, equals. It'll be over here by itself. All right, now we're ready to get started. Okay, you might want to pause here real quick and just read this. This is using that same equation, but I kind of worded it the way you'll see it more in A, the way I write problems, and B, in textbooks. That's a comma there. I just realized that it didn't come out very well. Okay, so so you're going to see wording like this, and people get themselves way overly confused, and there's a few reasons why. One of the main reasons is they feel like they have to understand deeply everything at once. Okay, but first of all, just read it over. Okay, and so to determine the shipping charge C in dollars at a certain store, the company uses this formula right here, where W is the package weight in pounds. All right, now this is a very common problem type, word problem type. The key thing is the problem gives us the equation that we're going to be working with. Okay, and so we're given the equation. You don't have to spend time thinking about why that equation, what it is what it is. Okay, and so you can if you want to, but if you find yourself getting bogged down with that, please move on and just take that as a given. It is given to you. So whatever these numbers mean, there is some deeper meaning to what they mean. But in general, if they're giving you an equation, you don't have to spend too much time thinking about where it comes from. But the key thing is to understand what those variables are and what they mean. Now remember what variables are. They're letters that we use in our math. Okay, so sometimes, especially when we're in an actual class, I'll say, what are the variables? And someone will say 1.10, or they might say 1.10W. Okay, and so those aren't the variables. The variables are the letters. Okay, so in these types of problems where you're given the equation, make sure you understand what the variables represent. Okay, and so I would write them out just to make sure you do. And so if you look up in that wording there, C is the shipping charge in dollars. Okay, and then W is the package weight, or we could just say the weight in pounds. Okay, like that. All right, and so you understand what make sure to understand what the variables are. Okay, now here's a kind of a question that I might ask then. I might ask, not what, but how much does it cost to send a, let's just say, a 5-pound package? Okay, so you might want to pause here and ask yourself how you would answer that. And then I'm going to go ahead and start working them. Okay, so whenever you see a question like this, don't overthink it. We're given the equation, like I just said. Okay, so now look at the question. How much does it cost? Remember, our one of our variables pertains to the cost to ship a 5-pound package. So this is a weight, and one of our variables is the weight. Okay, so what we're given here is we're given that W is equal to 5. Okay, and what are we trying to find? We're trying to find C. Okay, so we just take our equation, C equals 1.10W. By the way, if you're wondering why I'm writing those zeros at the end, it's because the charge is in dollars. To do the actual calculation, you don't need those zeros there. Okay, now what are we doing? We're given that W is equal to 5, so we're going to fill in 5 for that W. So we get 1.10 times 5. Remember, if you're filling numbers into an equation, I advise you to use parentheses there. Okay, and so now if you go and calculate this, 1.10 times 5 is 5.50. Okay, but then I'm adding on this 1.50. Sorry that I ran out of space and I'm writing so small. Okay, and then if you add those two numbers together, you get 7. All right, now don't stop there. We want to answer the actual question. Whenever a question comes in words, remember, I mean, even whenever we're talking about fractions, you should answer a question in the format that it came, whether it's just a straight math question or a word problem. So this is a word problem. It came in words, and so we should answer this in words. And so what is that saying? It costs, it's not the best verbiage there, starting with an it, but it costs $7. And it doesn't just, if you stop there, if you just say it costs $7, you're kind of implying that it always costs $7. Okay, it only costs $7 if the package weight is 5 pounds, and so it costs $7 to ship 5 pounds. Okay, like that. If you know the abbreviation for pounds, it's LBS. You could do that. All right, like that. And some better verbiage would have been to ship a 5-pound package. It costs you're charged $7 or something like that. But that'll at least cover our bases. It's just there's some sloppy English there, starting with the it. All right, but so that's the idea, and it's a very big problem type, and this one isn't one that should stump you. So anytime you're given an equation, just make sure you understand what the variables mean. And then once you get to the point where you're asked a question about it, you're going to be given a number, okay? Identify which of the variables that corresponds to, and you'll fill that in in the appropriate spot or spots, and then you find the other variable. Okay, so now I'm not going to go through this or write it out, but I could just as easily ask how many pounds can I ship for $5, where that 5 is actually a cost. So then I would be filling in the 5 for the C right here. And so I'll just write it over here really small. I don't have much room though. I would end up with 5 is equal to 1.10W plus 1.50. I'm not going to ask those questions yet because that requires some equation solving that we haven't got into quite yet. Okay, so now we want to look at a slightly more detailed situation that's very common, that the equation is often not given to us explicitly. Okay, but there's going to be some wording, and what we can do is we can derive that equation just by translating the wording and understanding where the variables are in that wording, and that's where things can get a little bit tricky. Okay, so we're going to start out here with a pretty basic example just to illustrate what we're going to be doing. Also notice that I didn't tell you what to find in this problem because I'm going to kind of lay it out the way I would in actual problems. And then thirdly, this actually the way we would usually word this problem is slightly different, and so it's a good opportunity to point out that wording and what to look for in some problems. Okay, so anyway, so let's look at this. So it says a person's daily pay is $16.25 times the number of hours worked. Okay, and so whenever we have this kind of situation, there's actually an equation hidden in this wording, but it's going to involve variables. And so the first thing we want to do here is we want to identify the variables, okay, and give them letter names, okay, like that. And so the key thing is that word variables, although I abbreviated it, this is my abbreviation for variables. We got to remember what the word variables means. That's things that can vary or things that can change. And so sometimes I have some people say this 16.25 is a variable, but it doesn't change at all. That's a fixed number, and so we call that a constant. All right, it affects the change, but it's not actually something that can change. That's fixed. Okay, and so whenever we want to try to identify the variables, we want to think about things that can change. So and think practically here in terms of working. Most days you're probably going to work 8 hours, or if you have a part-time job, 4 hours. But they can change. Things can come up, or you might have a part-time job where you work 4 hours one day and 6 the next day, and so on like that. Okay, so the number of hours worked can change. Okay, and so we have number of hours worked. I'm leaving a little bit of space because I'm going to write something in front of that in a minute. Okay, like that. And then what does the number of hours worked affect? It affects how much you get paid, or how much that person gets paid on that day. Okay, so we have this other variable, the daily pay. Okay, like that. Now, since we're going to want to work with variables, we want to give those names. All right, and so we want to give those letter names. So we want to just give them a name for what they're represented. We could use N to represent for the word numbers. We could use the letter W for work hours or something like that. And usually in these kind of contexts, and especially once you start asking deeper problems, that it's nice to give them letter names that help you remember what they are. I'm going to call this N. You may have picked W or something else. Okay? And then we have the daily pay, so I'll use P for that right there. So that's what we mean by giving them letter names. Okay? And then this is just typical wording that I give in problems. Give an equation relating the variables. Okay? And so we want to give okay, like that. And so the key thing is most of the time you're just translating. So I'm going to kind of abbreviate what I have written up there, but basically what that's saying is the daily pay is 16.25 times the hours worked, okay, or I'll say number of hours, number of hours, okay, like that. And see, if you write that, and if you've identified what your variables are and given them names, then it just becomes an exercise in translating. So what's a little bit different from the last video is we would always just say a number, and now we're going to actually be referring to something. And so here, daily pay, we want to translate that. Well, what do we have to represent the daily pay? It's right here, P. So I would write P. Okay, then we have this word is all by itself. So there's an equal sign, all right, like that. And then we have 16.25, and I'm going to point something out in a moment. You might be wondering why I didn't write the dollars there. 16.25, and then times, so there's a multiply, and then number of hours worked. Maybe it should have put that. I'll just abbreviate it right there. Number of hours worked. Well, again, remember now we have a variable to represent that, and so then I would use the letter N for that. And before we move on, just a quick note about why I didn't write the dollars in the equation. Some people will. Some people will put the dollars right here, but then also we should technically put hours right here. And see, these are called the units, all right? And so with the units, whenever you start to put them in an equation, they can clutter things up and make things a little bit more confusing. And so in wording, I do always include the units, and you should too. But whenever I go to an equation, I don't include them. But then once I get back to the answer, I always make sure to look back at things to make sure that I'm answering in the correct units. And then one other thing I just thought of is, remember, like in the last video, usually if we have a multiply with a number and a variable, we just use that juxtaposition idea. So really, the way most people would write this is just 16.25n, and assume that you know that that means multiplication. Okay, so just sticking with this for a minute. Now, the key thing is that once you have an equation, you can answer almost anything you want based on that. Okay, now you can't ask a question like, well, how much do they make in a year? You might be able to do some estimates on that, but you don't know how many days in the year they're going to work and something like that. But as long as your question pertains to either daily pay or number of hours worked that day, then you can answer any question you want. Once we get to equation solving, right now we can only answer a few questions. So how much do they get paid for 8 hours of work? Okay, and so a full day, right? Okay, and so like that. All right, and so this is, like I mentioned before, whenever we had the equation given, this problem didn't start with the equation given, but once we have it, then we can just treat it like it is. And so now the key thing is what kind of thing is this right here that we're given? We're given a number of work hours, and so we're given that N is equal to 8, and then it's asking how much they get paid, so we're trying to find P, all right? Like that. And so you just start with your equation, 6.25n, and we're saying n is equal to 8, so that means I would fill that in right there. And so I get 16.25, and then remember, try to fill things in parentheses. And the nice thing about that is, too, is now you can use your calculator. Just type it in just like it's written. If you type in those parentheses next to the 16.25, it'll know to multiply those. So then after you get that, and you calculate that, you'll get 130. So P is equal to 130. And so what is that telling us? The pay is $130 for 8 hours of work. Okay? Like that. And so again, always answer in the format of the question. The question was in wording, so you should answer that in wording. Okay, I just want to point out some alternate wording and this word per and how we can use it in translation. And so the way we would actually usually refer or word this problem is we would say that the person's daily pay is $16.25 per hour. Okay, like that. And so this is a little bit trickier here. Okay, and I'll just try to explain this here. And so if you remember, we would say, sorry, I didn't write the word pay, the person's daily pay. So we call that P. And then here we have this is, which means equals, right? But if you notice over here on this side, uh, we have that 16.25, and then it's the dollars per hour. That's called a rate. All right. So if you think about that, if they worked 1 hour, they would get 16.25, right? And then when they worked the next hour, they would get another 16.25. And then let's say they worked 3 hours that day, they would earn another 16.25. Okay? And so what did I do? I just added the same number together 3 times. And so that would be 16.25 times 3 in this case. All right? Well, what is 3? 3 is the number of hours. So that's N. Okay? Like that. And so what we're seeing here is that we get the same equation, of course, but that word per with a unit, with a rate attached to it, something per something else, like that. Then what you do is you take that rate and multiply it by the variable in that's after that per. And I know I wish I had a cleaner way to describe that there, but that word per can imply multiplication when your variable is that second part of the per relationship there. So yeah, let's do one more and kind of combining everything that we've talked about too. Okay, and so let's look at this problem right here. The charge to ship a package is $2.10 per pound with an added fee of $4. Okay, you might be wondering why I do these kind of shipping packages. They illustrate something important with what are called linear equations for later. But also, I do this all the time. I grew up in Texas and I ship stuff back home all the time, so I'm a little familiar with this kind of setup. Okay, but anyway, so the first thing we're going to want to do here is identify the variables and give them letter names. I'm just going to abbreviate it by saying identify the variables. Okay, again, they're things that actually change, and so you might be thinking this 2.10 is a variable, or maybe even this 4 is a variable, but those are fixed. Those don't change. Variables are things, that we'll usually describe in words. They won't be just a number. That doesn't make sense. Variables are things that change or that vary. Okay, so what could change here? Well, first of all, there's a weight associated in this problem. Okay, and that weight's affecting how much I get charged. Okay, and so those are the two things that can vary here. Is we can have the package weight, all right, and then we can have the charge, and we could be more explicit, the charge to ship, okay, like that. And so then you want to give them letter names, okay, like that. And so W is probably a good letter to use there. Some people, and I'll mention, some people just try not to think along those lines, and they always use X and Y. The problem with that is sometimes you get bogged down in a problem, and you forget what's representing what. But if you have more descriptive variable names, then that can help you remember what things are. Okay, and so here we have the charge to ship, so I'm going to use C for that. Okay, like that. Okay, so now let's get an equation relating the variables. Okay, and so the key thing is just think about that sentence, abbreviate it a little bit if you want it. We could take out some of the words, and so the charge to ship is $2.10 per pound with an added fee. Okay, added. There's that word added there. So that's going to be plus $4. Okay, or you could put in that word, and I'm just trying to be a little brief to get it on one line. Okay, and then once you have that, then it's just translating. There's some tricky wording in here that I talked about on the last slide. But the charge to ship, what variable do we have to represent that? C. Okay, and then is, so there's my equal sign. Okay, now here's the key thing right here is this 2.10 per pound. And so I have that 2.10, and then to figure out the cost from the weight, I'd want to multiply that by the number of pounds. So I'll get 2.10W. And then hopefully it's pretty obvious that we get plus 4 there. Okay, like that. And there's our equation right there. C equals 2.10W plus 4. Okay, like that. And then, I could ask any question based on the weight. Okay, how much to ship 8 pounds, like that. Okay, and so just realize, what are we given here? We're given a weight. Okay, and so what letter do we have to represent that? W, and that's going to equal weight 8. And what are we trying to find? How much to ship? And so we're trying to find the C. Okay, and so we just take our equation like that, and we're filling in 8 for W. So we have C is equal to 2.10 times 8 plus 4. Okay, and so then we just follow a order of operations, or you could type that whole right side in on your calculator there. We're going to get 1680 plus 4, like that. Let me check that. I did it in my head. Yes. All right. And then whenever you add those two numbers, you're going to get 20.80. Okay. And we're almost there, but then you want to answer in the context. All right. And so what is that saying? It costs $20.80 to ship 8 pounds. We could say at the store. And that's the thing. In terms of the wording for the answers, try to think about the way you would answer it best. There's just some key elements. Whenever you have two variables, then in your answer you should refer to both variables, okay? It doesn't always cost $20.80 to ship a package there. It only costs this amount whenever the package weight is 8 pounds, all right? And so keep that in mind. We don't want to just say it costs $20.80. You want to include this. But yeah, there's lots of different ways to word it. You could have worded it backwards. You could have said to ship 8 pounds, the cost is $20.80. You could use that looser grammatical wording. It costs $20.80 to ship 8 pounds, etc. But the key thing is definitely try to refer to both of those variables whenever there are two variables. Okay, so I'm going to leave it there. I hope that helps as always, and as always too, feel free to let me know if something confused you. All right, all the best.